Hello everyone. Today let's get into the chapter called current electricity, right? So now we need to get ready to solve the numerical problems that is involved in this chapter. See, numerical problems are based on Kirchhoff's voltage law, right? So before getting into Kirchhoff's voltage law, I will first get into the basic concepts that is necessary to solve the problem. So if you are able to understand the concept, then for solving the problem, it will be easier for you to arrive at the desired answer, right? So I'll give you a simple scenario, right? Let us assume that a branch AB consisting of a resistor. This is a branch AB. This branch AB consists of a resistor of value 5 ohms. Yes. Let us assume that a current is traveling through this resistor, and I am going to name the value of the current as I1. Listen carefully. AB is a branch. This branch has a resistor of value 5 ohms, and I am passing a current of value I1 through the resistor in this AB branch, and my direction of travel will be always in the clockwise direction. My direction of travel will always be in the clockwise direction. Inside a closed loop, my direction of travel will always be in the clockwise direction irrespective of any scenarios, right? Let it be in the clockwise direction. Now, what I'm going to do is, now I'm analyzing that a current I1 and my direction of travel both are traveling in the same direction, right? My direction of travel is in the clockwise direction, and while I am traveling in the clockwise direction, I encounter a current of value I1 that is passing through this 5 ohm resistor, right? So when the direction of travel of the current and the direction of travel of this direction both coincide with each other, then I will put or introduce a negative sign in the problem. I will introduce a negative sign, and along with this negative sign, I will multiply the value of the current, that is I1, into the value of the resistance, that is 5. So my answer is minus 5I1. For this scenario, when my direction of travel is in the clockwise direction, and in this direction while traveling, if I encounter any current of value I1 or I2 or whatever it is, if it is also moving along with me, going along with me, then I will introduce a negative sign, and I will multiply the value of the current along with the value of this resistance. So this is the first scenario, right? In a case if like this arises, then my answer will be like this. What is the second scenario? My direction of travel, as I told, won't change. It will be always in the clockwise direction. But what happens if the direction of current is in the opposite direction? First scenario, the direction of current is from A to B. Now the direction of current is from B to A, and let us assume that the direction of the value of the current is I2. I1 is a current flowing from A to B. So from B to A, I am assuming another current that is that has a value of I2, right? So if this is the case, what will happen? If this is the case, means that is my direction of travel is in the clockwise direction. While traveling in the clockwise direction, I encounter a current which is flowing in the opposite direction to the direction of my travel. If this is the case, means then I will automatically introduce a positive sign, and again I will multiply the value of the current, that is I2, along with the value of this resistor, that is 5. So my answer will be 5I2. 5I2 will be the value, right? You got it? This 5I2, positive of 5I2 will happen if my direction of travel is in the opposite direction to the direction of the flow of electric current through the branch which is holding the resistor of value 5 ohms, right? This is the scenario. Okay, What is the third scenario? Third scenario is, what will happen if I have a battery like this? AB is a branch which is having a battery of 10 volts, let us assume. Okay, and again now I am saying the same concept. My direction of travel will always be in the clockwise direction. So this is the scenario. So when I am rotating in the clockwise direction, if I keep on rotating in the clockwise direction, and in my way, if I happen to notice a voltage source or a battery or whatever it is, okay, if I happen to notice a battery such that I encounter the positive terminal first and the negative terminal second, if it happens, then my value for this entire scenario will be minus of 10. 10 is nothing but the value of the voltage source. Minus 10. If during my clockwise direction, during my direction of travel in the clockwise direction, if I happen to notice a positive terminal first, then a negative terminal at the second stage, then I will introduce a negative sign and I express this voltage as minus 10, right? In this fourth scenario, if the same branch is here, that is, let us assume it is CD. CD is a branch which is having a voltage source of 20 volts. Let us assume 20 volts. Okay, CD is a branch having a battery of 20 volts. Battery of value 20 volts. Now, here in the third scenario, there will be plus and minus. Now I am going to reverse the polarity of the battery. So what will happen? Here it will be minus and here it will be plus. Okay, this is the amendment which I am doing in the scenario 4, right? So again, as usual, my direction of travel will be in the clockwise direction. So during my travel, if I happen to notice a battery such that the negative terminal of the battery comes first and the positive terminal of the battery comes second, then I will automatically introduce a plus sign. I will automatically introduce a plus sign and I'll put 20 volts, 20 plus 20. So plus 20 is the value of this one, of this entire branch. This is how I express the branch with the help of a Kirchhoff's voltage law, KVL. Okay, these are the 4 scenarios. Scenario 1 is current moving in this direction, I1, which I explained. Scenario 2 is this one. Scenario 3 is this, and scenario 4 is this one. Based on the 4 scenarios, now I'm going to solve a problem that is based on Kirchhoff's voltage law, right? Let's get into the problem. Now I'm going to draw an electrical circuit diagram. In that, I'm going to determine various branch currents. Okay, the value of various branch currents is what I'm going to determine now. That is purely based on Kirchhoff's voltage law, right? Okay, so let's get into the problem. Now I'm going to draw a electrical network. While drawing the electrical network, I will explain the diagram. AB is nothing but it is a branch of value 4 ohms, right? AB is a branch of value 4 ohms. BC is also another branch having a resistance of value 2 ohms. BC, right? Again, CD is another branch having a resistor of value 2 ohms, and AC is another branch which is having a voltage source of 10 volts and another resistor of value 1 ohm is connected in series with this voltage source, right? Now this is point D. Now again I'm connecting AD and I'm naming AD as a branch, and I'm connecting another 4 ohm resistor, and I'm connecting another 4 ohm resistor in this branch AD. Now finally I am connecting the junction B and D with another branch which is having a voltage source of value 5 volts, and I'm naming this point as E. This is the circuit diagram which we are going to analyze. After analyzing the circuit diagram, we are going to calculate the branch currents. We have individual branch currents that is flowing through each and every branch, and we are going to finally determine the value of those currents, right? That is the principal work which we are going to do. You might be getting a problem in your examination, like they will give you a circuit diagram like that, and they will ask you to find the value of branch currents, right? This is what they do. So this is the circuit diagram which is being given to you, right? Now what is the next step you are going to do? Next step is that you need to mark the direction of the currents. You need to mark the direction of the currents. While marking the direction of the currents, you need to name the currents. First thing, you need to mark the direction of the currents, and after marking the direction of the currents, you need to name the currents. So it will be useful for you to identify the value of the branch currents finally, right? Now let's start. Here in this entire circuit loop, you have two voltage sources. One is 10 volt, another one is 5 volts. So let's start with the voltage source which is having a higher value. Let's start with the voltage source which is having a higher value. In this network we have two voltage sources, and I am going to start with the voltage source which is having a higher value. So what is the thing is, for me now 10 volt is greater than 5 volts. So I am assuming that a current, this 10 volt battery source is supplying a current. Okay, it is supplying a current. So the current usually flows from positive terminal to negative terminal, right? So in this battery, this is the positive terminal, the bigger line is the positive terminal, and the short line is the negative terminal, right? This you would have learnt in your lower classes. So this is the voltage source, and this is the positive terminal. From this terminal I will analyze the current. Let us assume the value of the current is I. Let us assume a current of value I is flowing from the battery whose value is 10 volts. It is flowing out of the battery. Once the circuit is closed, the electric current will start flowing, right? This is the basic principle. So when the circuit has been closed and the battery has been connected, a current of I flows from the positive terminal of this 10 volt battery, right? So now this current I1 will go. At this junction A, what is going to happen is the current is going to divide into two parts. Whether it's going to divide, it's going to bifurcate into two branches. Here at this junction A, you have two branches. One is AB, another one is AD. Now the current will start analyzing that, because at this point, till this before this point A, the current will be it will be having one single value, that is I. At this point, at this junction point A, the current will be triggered to bifurcate into two values in various branches, right? So we have two branches, AB and AD. Now this I current will reach this junction A, and from A it will divide into two different currents. It will divide into two different currents. The value of the current is I. Don't get confused. The value of this current is I. Okay, and the current which is flowing from A to B is nothing but it is another current. Okay, let us assume the current which is flowing in this branch AB, let us assume the name or value of the current as I1. I hope you can understand what I'm trying to say, right? This is at this branch AB, a current I1 gets divided. I is divided into two currents. One is I1, and the current which is flowing through the branch AD is nothing but I minus I1. This is I minus I1. This is how current bifurcates or divides itself in a junction point, right? I is at junction A, the current I is divided into two currents flowing along AB as I1 and through the branch AD as I minus I1, right? Now I1 current will flow till this point B. At this point B, what will happen? Again, there is two branches. B is a junction. After this junction, you have two branches that is moving out of B, right? So now again this I current will flow till B, and again it will start to bifurcate into two branches. So let us assume the current that has been divided along the branch BC, as I2. Okay, the current that is flowing through the branch BC be I2. Now, what will be the current that is flowing through this branch BD? The current that is flowing through the branch BD. Let us assume the current that is flowing through the branch BD as, this current is I1. I1 is divided into, this current is I2. So this current will be I1 minus I2. You got it? I1 current at this junction is divided into I2, and other current is nothing but I1 minus of I2. So this value I1 minus I2 flows through the branch BD through a voltage source of 5 volts. So now what will happen at this junction C? What is going to happen at this junction C? So we have analyzed that across all the branches the current is flowing, but for the branch CD we haven't analyzed what is the current. So at this branch CD another current will flow. How it will flow? From B to C the value of current is I2, and from C to A another current is flowing, that is I. So what will happen? The current that is flowing through the branch CD will be I2 minus I. I2 is a current which is flowing till this point C. At C, I is a current which is moving out of C. So what will happen? The current that is flowing through the branch CD will be I2 minus I. This is how you need to name the currents. This is how you need to mark the direction of the currents. If everything is perfect, then your answer will be perfect, right? Now we have 3 loops. This is one loop, this is second loop, and this one is third loop. This is a loop. A B C A is a loop. Again A C D A is a second loop, and B E D B C is another loop. So in this electrical circuit you have 3 loops, 3 closed loops. This circuit consists of 3 closed loops. Okay, so we need to apply Kirchhoff's voltage law in this entire loops. In all the 3 loops we need to apply Kirchhoff's voltage law. We need to get simultaneous equations, separate equations for each and every loop, and we need to solve all the equations so that we will be getting individual branch currents, right? So our work is over with this circuit diagram. This is how you need to do a circuit analysis, right? Now what I'm going to do is I'm going to consider this loop. Okay, I'm going to consider this loop. Let us assume that consider loop A B C A, A B C A. Now I am going to apply KVL. Right? Now I am going to apply KVL. So again, my direction of travel inside the loop will be in the clockwise direction. Again, in this loop also, A, C, D, A also, my direction of travel will always be in the clockwise direction. Before starting the lecture, I have told you about the basic scenarios. We have analyzed the basic 4 scenarios. Based on the 4 scenarios, we are going to solve this problem, right? So again, in this loop, I am traveling in the clockwise direction. Similarly, in the third loop also, my direction of travel is going to be in the clockwise direction. There won't be any change in my direction of travel. Always I flow in the clockwise direction. Okay, now we have considered this loop A, B, C, A, right? This is the problem. This is the problem, right? Now I'm going to apply KVL to this closed loop. I'm going to apply KVL. So let's start. Now what will happen? My direction of travel is in the clockwise direction. So while traveling in the clockwise direction, like this, I keep on traveling. While traveling, I encounter a current I1 which is also going along with me. And what is it is going along with me, and it is entering into this 4 ohm resistor. So if this is the case, my value will be minus of I1 into the value of the resistor. Again I am coming here. Again I am rotating in the clockwise direction. While rotating in the clockwise direction, I encounter another current I2 which is flowing along with me. Okay, it is flowing along with me. So again I am introducing a negative sign, and I am putting the value of current I2, and along with that I am multiplying with the value of the resistor, that is 2. Again I keep on rotating here in the clockwise direction. While in the clockwise direction, what will happen? A current I flows through the branch CA. While traveling in the clockwise direction, I encounter a current I encounter this because I is flowing from C to A. While traveling in the clockwise direction, I encounter a current that is also flowing along with me. So my value will be minus I into the value of this resistor into 1. You got it? Next, while I am traveling in the clockwise direction, I encounter a negative terminal first and a positive terminal in the second stage. So what will happen when I encounter a negative terminal in the first stage? I need to put a plus sign, and I need to introduce the value of this voltage source, plus 10, right? Plus 10, that's all. Plus 10 means this loop is, and the complete loop is over. So I am equating this to 0. This is what the Kirchhoff's law states, right? The sum of the voltage drops through inside a closed network will be equal to 0. So I am equating it to 0. So what will happen? Minus I minus 4 into I1 minus 2 into I2 plus 10 equal to 0. You got it? Minus I minus 4 into I1 minus 2 into I2 plus 10 is equal to 0. Now I am going to change the signs. So what will happen if I change the signs? It will be I plus 4 into I1 plus 2 into I2 minus 10 is equal to 0. I plus 4I1 plus 2I2 minus 10 is equal to 0. Now I am going to take this 10 to the right hand side. So it will be I plus 4I1 plus 2I2 is equal to 10. Now I am going to name this equation as equation number 1. You got it? Now I have framed first equation we have framed, that is equation number 1. That is I plus 4I1 plus 2I2 is equal to 10. Right? So I'll rub this one. So we have calculated the equation. We have formed the equation using the first loop. Using the first loop, we have arrived at an equation. So I am erasing this part. I'm erasing the entire part, okay, and I'm going to write this equation here. I plus 4i1 plus 2i2 equal to 10 is equation 1. Okay, I got this first equation. I plus 4i1 plus 2i2 is equal to 10, first equation. Okay, now our duty is to find the another equation. We are going to frame another equation using this closed loop. Okay, similarly like the one which we did before while forming equation 1. So what is the area of the loop that need to be taken into consideration is ACDA, right? Consider ACDA. Why I am putting ACDA and not ACD? ACDA. This is ACDA. If I say ACDA only, the loop will be closed. If I say only ACD means it will be partially closed. Partially closed means current won't flow. If current won't flow, it will become an open circuit. So no, Kirchhoff's voltage law won't be applied because KVL usually applies in a closed network. So that is the reason why I am closing this circuit ACDA. This is very important. Students usually forget to close the loop ACD, just like that they say BED, that's all they put. No, it is wrong. You need to close the loop. Okay, ACDA means the loop is being closed. Okay, so this is very important, you need to take into consideration. Okay, so ACDA is the loop. In this loop you are going to apply KVL. Okay, so my direction of travel is in the clockwise direction. I keep on rotating in the clockwise direction. While rotating in the clockwise direction, I encounter a battery source which is having a positive terminal at the first stage and the negative terminal at the second stage. So when I encounter a battery which is having the positive terminal at the first stage, what will happen? Positive terminal at the first stage and the negative terminal at the second stage, I will express the value of the voltage source in my calculation as minus 10, right? Minus 10 will be the value. Then after that what will happen? This current I is flowing from C to A, this current I is flowing. So while traveling in the clockwise direction, again I encounter a current which is coming in the opposite direction. So if a current is coming in the opposite direction, I will take the value of the voltage as plus I into 1. You got it? See, again I'm rotating in the clockwise, I'm moving in the clockwise direction. At the first stage I'm encountering a battery. In the first stage, the positive sign is the one which I'm encountering. The positive is the first terminal which I'm encountering. So I'm adding minus to it and I'm expressing the voltage as 10. So minus 10. And after that, I face another current that is moving in the opposite direction of my direction of travel. So I am giving this as expressing this part as plus I into this 1. 1 is the value of the resistance. Again, while rotating in the clockwise direction, I find another current I2 minus I is going along with me. I2 minus I is a current which is traveling along with me. Okay, while traveling in the clockwise direction, I find another current I2 minus I. It is moving in the same direction like the direction of my travel. So if it is moving in the same direction, means what I need to do is I need to add a negative sign. I need to introduce a negative sign and I will multiply the value of the current along with this resistance. So it will be 2 into I2 minus I. I2 minus I. Minus 2 into I2 minus I. So this part is over, this calculation part is over. Now again I'm coming here. While traveling in the clockwise direction like this, I encounter a current which is moving in the opposite direction. So any current that is moving in the opposite direction to the direction of my travel will be given a positive value, and I'm going to multiply the value of the current along with the resistance. So what will happen? It will be 4 into I minus I1, 4 into I minus plus 4 into I minus I1, which will be equal to 0. You got it? This is how I'm going to form the second equation. So how it works? My direction of travel is in the clockwise direction. When it comes to 10 volts, because I'm encountering a positive terminal first, I'm going to add a negative sign, and I'm expressing this 10 here. Then again, while traveling in the clockwise direction, I am experiencing another force which is traveling in the opposite direction of mine. So I am giving a positive value. Along with the positive value, I am multiplying I into 1. Again, while traveling in the clockwise direction, I encounter another current which is traveling along with me in this branch. So I'm introducing a negative sign, and I'm multiplying this value of the current along with the value of resistance. Then again I'm moving in the clockwise direction. While moving in the clockwise direction, I find another current which is flowing in the opposite direction, to the direction of my travel. So again I'm introducing a positive sign, and I'm multiplying this value of resistance along with the value of the current, and I'm equating all the quantities to be equal to 0. That is equal to 0. This is how it works. Now to simplify, it is minus 10 plus I minus 2I2 plus 2I plus 4I minus 4I1 equal to 0. You got it? Minus 10 plus I minus 2I2 minus plus 2I plus 4I minus 4I1 is equal to 0. Right? Now again, take the items. If I take the item, how many items I have? 1, 2, 3, right? 4, 5, 6, 7. You have 7I, right? You have 7I. Now I am going to take the I1 terms. How many I1 terms you have? You have only one I1 term. Minus 4 into I1. Right? So now I am going to take I2. How many I2 you have? You have only one I2. Minus 2 into I2. Right? 2 into I2. Okay, you have 3 items, 4, 5, 6, 7I minus 4I1 minus 2I2 minus 10 equal to 0. Right? You got it? This is how the equation will be formed. Now I am putting 7I minus 4I1 minus 2I2 is equal to 10, and I am naming this equation as equation number 2. 7I minus 4I1 minus 2I2 is equal to 10, and I am naming this equation as equation number 2. So along with this, with the help of this equation, with the help of this loop ACDA, I am able to form an equation 7I minus 4I1 minus 2I2 is equal to 10, and I am going to name this equation as equation number 2. Okay, now I am going to rub this one. Okay, I have erased this one. So separately I will note this equation 7I minus 4I1 minus 2I2, 7I minus 4I1 minus 2I2 is equal to 10. This is equation number 2, right? You should be very careful while changing or while taking the equation to while writing the equation in another part of the sheet, answer sheet and all, sometimes you might be making a mistake, like plus, instead of plus you will put a negative sign, or instead of negative sign you might put a positive sign. So 7i minus 4i1 minus 2i2 is equal to 10. Always recheck your calculations, okay, then and there, so that you won't be making mistakes while solving problems. So now the final part is you are going to consider this one, the third loop, that is BEDCB, right? Now consider loop BEDCB. Okay, this is the loop that needs to be considered, and KVL needs to be applied to this loop, that is BEDCB, right? So let's start. Now my direction of travel is in the clockwise direction, right? I keep on rotating in the clockwise direction. So while traveling in the clockwise direction, I encounter a battery source, I encounter the voltage source with the plus terminal. This is the minus terminal. So when I travel in the clockwise direction, and if I experience a positive terminal in the first stage, what will happen? I need to introduce a negative sign. And I express the voltage source as 5. So minus 5, right? So minus 5. Now again I am traveling in the clockwise direction. While traveling in the clockwise direction, I encounter a current I2 minus I. Which is flowing in the opposite direction of my travel. So what I will do, I will add a positive sign, and I will multiply the value of the resistor along with the value of the current. So that will be 2 into I2 minus I. Right, that will be 2 into I2 minus I. Again I keep on rotating. While rotating, I encounter another current I2. This is how I keep on rotating. While rotating in the clockwise direction, I encounter another current I2 that is flowing in the opposite direction. If it flows in the opposite direction, then I will add a positive sign and I will multiply the resistor value and the current value. Okay, so the answer will be plus 2 into I2. It will be plus 2 into I2. So plus 2 into I2. So the entire loop is over. See, while traveling in the clockwise direction, I will encounter this battery source. Since I encounter the positive terminal at the first stage, I will add a negative sign. I will introduce a negative sign and I will put this value of this voltage here, minus 5. Again I am coming down. While going to this point, I keep on rotating in the clockwise direction. While rotating in the clockwise direction, I encounter another current I2 minus I, which is flowing in the opposite direction. So I will multiply the current along with the value of the resistance. So my answer will be plus 2 into I2 minus I. Okay, again I keep on rotating in the clockwise direction. While moving in the clockwise direction, I happen to encounter a current which is moving in the opposite direction. While a current is moving in the opposite direction, what I do is that I will multiply this quantity and this quantity and I'll introduce a positive sign. When I introduce a positive sign and multiply these two quantities, it will be 2 times of I2. So 2 times of I2, so the entire equation I am going to equate it to 0. I am going to equate it to 0 because the sum of all the voltage drop in a closed loop will always be equal to 0. Now, how we are going to do it? Minus 5 plus 2 into I2 minus 2I plus 2I2 equal to 0. You got it? So minus 5 plus 2I2 minus 2I plus 2I2 is equal to 0, right? So now take this minus 2I. You need to rearrange the terms. Minus 2I. So plus 2I2 plus 2I2. So what will be the result? It will be plus 4I2. Minus 2I plus 4I2 minus 5 is equal to 0. You got it? Minus 2I plus 4I2 minus 5 is equal to 0. So I am going to change the signs. So it will be 2i minus 4i2 plus 5 equal to 0. 2i minus 4i2 plus 5 is equal to 0, right? So 2i minus 4i2 is equal to minus 5, which will be equation number 3. So finally we solved this loop. Okay, we solved and we got a equation that we are naming it as equation number 3. So in this entire electrical loop we have obtained 3 equations. We have obtained 3 equations, right? So this is what is all about. The calculation is all about. So now what I'm going to do is I'm going to rub this one. I'm going to rub this one. And now I'm going to put this equation number 3 I'm going to copy over here, right? 2i minus 4i2 2i minus 4i2 is equal to minus 5. Equation number 3, right? 2i minus 4i2 is equal to minus 5. This is equation number 3. So finally we have solved the electrical loop. The individual electrical loop we have solved and we have obtained 3 equations. Now our duty is to solve these equations simultaneously, and we need to find we need to determine the individual branch currents, right? So now what are we going to do now? So I plus 4i plus 2i2 is equal to 10. 7i minus 4i minus 2i2 is equal to 10. 2i minus 4i2 is equal to minus 5. So now what are we going to do is, let's take equation number 1 and 2. You got it? Taking equation 1 and 2. So it will be I plus 4i1 plus 2i2 is equal to 10. This is equation 1. And second one is 7i minus 4i1 minus 2i2 is equal to 10. This is equation number 2. Right? 7i minus 4i1 minus 2i2 is equal to 10. So we need to see how we need to do this problem. So 2i2. So what I can do is I can cancel the same values. Okay, 2i2 cancel. Similarly 4i1 will get cancelled. So what will be the result value? 8i is equal to 20. Therefore I is equal to 20 divided by 8. So what will be 20 divided by 8? I2 is 20 divided by, so 2 4s are 8, 2 10s are 20, 2 2s are 4, 2 5s are 10. So 5 divided by 2, 4 1.0, 2 5. So it will be 2.5 ampere. Therefore I is equal to 2.5 amperes. This is the value of the current. You got it? Taking equation number 1 and equation number 2, I have solved both the equations and I am ready. I automatically got the value of the current I. I is nothing but 2.5 ampere. Ampere is the value of the the unit of this electric current. So it's very important that you need to express the value of the current along with the unit. So I is equal to 2.5 ampere. So I am writing the value over here. I is equal to 2.5 ampere, right? 2.5 ampere. Fair enough. Next, what we are supposed to do is we need to take another thing. Okay, so let's take equation number 3, right? So I am taking equation number 3. So if I take equation number 3 is 2i minus 4i2 is equal to minus 5, right? 2i minus 4i2 is equal to minus 5. So we know the value of I. I is nothing but 2.5 ampere. So you need to substitute in this value. So 2 into I is 2.5 minus 4 into I2 is equal to minus 5. You got it? So 2.5 into 2. 2 5s are 10, 1, 2 2s are 4, 5. So that is nothing but 5. 2 5s are 10, 1, 2 2s are 4, 5. 5.0. This is 5.0 minus 4I2 is equal to minus 5. Okay, so minus, okay, 5 minus 4I2. 5 minus 4I2 is equal to minus 5, or minus 4I2 is equal to minus 5 minus 5. Minus 4I2 is equal to minus 5. I am taking this plus 5 to the to the right hand side, so it will be plus 5 will become minus 5. So that is nothing but minus 10. Minus 10. So what will happen is, I am writing over here minus 4I2 is equal to minus 10. So I2 will be 10 divided by 4. I2 is nothing but 10 divided by 4. 2 2s are 4, 2 5s are 10, right? So 5 divided by 2, 2 2s are 4, 1.025. So I2 is nothing but 2.5 ampere. So I2, the value of I2 is nothing but 2.5 amperes. While solving this, I got this equation. While solving, I got this equation. I simplified the equation and I arrived at the solution. The solution is nothing but the value of the electric current I2 along with its unit, that is 2.5 amperes. Right? Minus 10. 10 by 4, I2 is equal to 2.5 amperes. So I am writing here, I am registering the value of the current here as I2 is equal to 2.5 ampere. Right? So now what I am going to do is, I got the value of I got the value of I2. So remaining is I1. I need to find the value of I1. Okay, so how am I going to do it? I need an equation. I need an equation where I should have the values of I and I2 in order to find the value of I1. So I am taking the equation number 1, taking or considering equation 1. If I consider equation 1, what is equation 1 is? Equation 1 is I plus 4I1 plus 2I2 is equal to 10. So I got the value of I got the value of I2. So remaining I1. So using this equation, I can determine the value of I1. So I is 2.5 plus 4 into I1 plus 2 into I2 is 2.5. That is equal to 10. So 2.5 plus 4I1 plus 2.5 into 2 is nothing but 5 is equal to 10. Okay, so 4I1 plus 5 plus 2.5 is 7.5 is equal to 10. So 4I1 is equal to 10 minus 7.5. What is 10 minus 7.5? It will be 2.5. It will be 2.5. Therefore, 4I1 is equal to 2.5 and I1 will be 2.5 divided by 4. I1 will be 2.5 divided by 4. So what will be the value? 2.5 divided by 4. 4 6 are 24, right? It will be 0.6 amperes. 0.6 ampere. So therefore, the value of I1 is nothing but 0.6 amperes. You got it? So now we have found the value of I1 as 0.6 amperes. So I am registering the value as I1 is equal to 0.6 amperes. So using the three equations which I obtained by solving this electrical network, I obtained three equations, and with the help of the three equations I have solved all the equations, and I have got the individual values of the electric current. So I got the value of I got the value of I1, I got the value of I2. Right? Now we need to find the branch currents. So what are the branch currents here in this loop? Branch currents is I is one branch current, I1 is one branch current, I2 is another branch current, I minus I1 is a branch current, I2 minus I is a branch current, and I1 minus I2 is also another branch current. So we have totally 1, 2, 3, 4, 5, 6 branch currents we need to find now. So that is very simple. Just it's a process of addition and subtraction, and we can find the value of the current. Okay, now we have arrived at the final stage of the problem. So let's start. Okay, now we know that I2 and I1, right? So now we need to find, so let us assume that let AB be the branch. AB is a branch, therefore the branch current is I1. What is the value of I1 here? I1 is nothing but 0.6 ampere. So for this branch AB, the value of the current that is flowing through the branch AB is nothing but 0.6 amperes. Next, how about the value of the current that is flowing through the branch BC? The value of the current that is flowing through BC is nothing but I2, and the value of I2 is 2.5 amperes. So we got the value of this branch current. Now what is the value of the branch, the current that is flowing from C to A? The current that is flowing from C to A is a branch. The current which is flowing through the branch is I. So what is the value of I? I is nothing but 2.5 ampere. Right? So now we need to analyze this branch AD. So we need to find the branch current AD. And what is the value of the current? The value of the current that is flowing through the branch AD is nothing but I minus I1. So AD is nothing but I minus I1. So what is I minus I1? I, we know it is 2.5, and I1 value is 0.6. So 2.5 minus 0.6. So 6, it will be 9.1, right? 5, 6, 9. So 1. So it will be 1.9 ampere. So the current that is flowing through AD is nothing but 1.9 ampere. The current which is flowing through the branch is 1.9 ampere. So now how about the current that is flowing through the branch CD? So the current that is flowing through the branch CD is nothing but I2 minus I. So you need to know both the values. What is the value of I2? I2 is nothing but 2.5 minus I. I is 2.5 minus 2.5. Now here comes the mystery. You might be confused. Okay, 2.5 minus 2.5. So I2 minus I2 is 2.5 minus I is 2.5. So 2.5 minus 2.5 will be 0. So therefore, according to the calculation which we have performed, we have found that there won't be any current that is flowing through the branch AD, because the value will be 0. So no current will flow through the branch CD. Right? Fine. How about this branch BD? So that is the final branch. 1, 2, 3, 4, 5, 6. Sixth branch. Okay. This is the last part. So the branch BD. What is the current that is flowing through the branch BD? It is nothing but I1 minus I2, which is equal to I1 minus I2, that is equal to, which is, what is the value of I1? I1 is nothing but 0.6 minus, what is the value of I2? I2 value is 2.5. So the value is I1 minus I2, that is I1 minus I2 is 0.6 minus 2.5. So what is the value of 2.5? What is the value for that 2.5 minus 0.6? So it will be 1.9. So the value will be minus 1.9 amperes, right? 2.5 minus 0.6. 2.5 minus 0.6 is nothing but 5, 6, but not 9. 1.9. So since minus is attached to the greater value, you need to attach this minus 1.9. So since the value of the current is minus 1.9, from B to D, we have found that the value of current is minus 1.9 ampere. We usually don't get the value of current in negative values. We won't get. We usually get a positive value. 5 amps, 6 amps, 7 amps, 1.9 amps, 1.8 amps, all are positive values of electric current. But why this, in this problem we are getting minus 1.9? So from B to D, while we have assigned the direction of current like this, from B to D, the current is flowing from B to D. So B to D is minus 1.9, but usually you don't get negative values, so you get a positive value. So we get only, instead of minus 1.9, we need to get 1.9 amperes. If it is like that, means now from the calculation we understood that the current won't flow from B to D, but instead it flows in the opposite direction, that is from D to B. D to B, it is 1.9 ampere. It is not a problem if you get a negative value. If you get a negative value, you need to attach a comment stating that the current flows from, since the value of the current is negative, the current flows from D to B instead of B to D. You need to add a comment, that's all. If you add a comment, means that's all, it's not a problem. So your entire problem is done. Okay, this is how you need to solve electrical loop. Complicated networks like this, it will be asked in examination, and you need to analyze each and every loops. You need to mark the corners, you need to mention the direction of the currents, you mark the direction of the currents, you need to name the currents. After naming the current, you need to get 3 simultaneous equations. After getting the equations, you need to solve those equations, and you need to get individual values. After getting the individual values, you need to substitute in the direction of in the currents, okay, like I1 minus I2 or I minus I1. Based on the values which you are getting, you need to substitute, and you need to find the individual branch currents. This is how we need to find individual branch currents. Okay, I hope you would have understood the entire concept that is behind this Kirchhoff's voltage law. This is how the problem is based on the application of Kirchhoff's voltage law. Thank you.